good evening, and a quiet welcome to this calm corner of cosmic exploration. Tonight, our gentle gaze will drift far past the familiar boundaries of our own home galaxy, the Milky Way. We shall embark upon a silent journey of discovery to unveil a majestic presence, a colossal entity that gracefully resides within the velvet depths of the eternal night sky. This celestial titan, this ancient wanderer, is known as the Andromeda Galaxy. For countless millennia, to the unaided human eye, Andromeda has presented itself as merely a delicate, almost ethereal whisper of light, a misty, indistinct patch softly diffused against the inky canvas of the heavens above. Yet, this elusive shimmer, this subtle suggestion of something more, conceals an astonishing truth. In its true, breathtaking reality, Andromeda unfolds as an immense, truly colossal, cosmic metropolis, a sprawling system teeming with the radiant energy of more than 1 trillion stars. Imagine, if you will, such an unimaginable multitude, each a distant sun, each burning with its own steady intensity, a collective symphony of stellar brilliance. Its magnificent spiral arms, like vast, celestial ribbons, sweep majestically across an incredible expanse, stretching for hundreds of thousands of light years from their luminous core out into the quiet dark. These grand, curving structures glow with a gentle, almost dreamlike radiance, illuminating the profound blackness of the intergalactic void with their ancient, shimmering light. Each arm, a river of stars, flowing silently through the deep. The very light that now, after its immense voyage, finally touches our eyes, began its journey, its patient, unwavering trek across the cosmos over 2 million years ago. This was a time, a primordial epoch, long, long before the very first footsteps of humanity's ancestors left their subtle imprints upon the soft, undisturbed soils of an ancient Earth. Every single glimmer, every faint spark of that arriving light carries within its essence a silent, unfolding narrative, a profound story of a faraway sun, perhaps a vast, glowing cloud of cosmic dust, or even the untold tale of a distant world, a silent sphere that no human presence will ever possibly reach. Deep inside those expansive and gracefully curving arms, stars are perpetually in the process of formation, gently gathering from swirling nebulae, while others encounter one another in slow, gravitational dances, and still more are softly and serenely fading away into the quiet, inevitable cosmic night. Andromeda, you see, is far more than merely another isolated point of illumination in the immeasurable vastness of the night sky. It stands as our closest and most magnificent celestial companion, a sister galaxy of immense scale, moving with a slow, unwavering purpose, steadily approaching us through the silent, intervening void. In a time, perhaps billions of years, from this very moment, this grand galaxy will inevitably and gracefully meet our own Milky Way, and from that immense, cosmic embrace, something entirely novel and breathtakingly new will majestically form. Andromeda, this cosmic marvel, holds the distinction of being the closest of all the large galaxies to our own home. Among the countless, shimmering galaxies that are scattered like cosmic jewels across the boundless canvas of the observable universe, Andromeda stands out with a unique prominence as the nearest, truly great spiral galaxy to our Milky Way. It quietly resides just beyond the threshold of 2 million light years away. This distance, though it might sound absolutely staggering to our human minds, is, in the grand, immeasurable scale of the entire cosmos, considered a relatively short, a remarkably intimate, celestial span. Yet, despite its relative proximity, this gulf of space remains vast, almost incomprehensibly so, stretching far beyond the limits of our easy, everyday imagination. This remarkable closeness, this cosmic neighborliness, bestows upon astronomers a truly rare and invaluable opportunity. It allows them to meticulously study a galaxy that mirrors, in many profound ways, our own home system, but from a unique, external vantage point. This external view offers an unparalleled insight into the fundamental processes that govern the formation, the intricate dance, and the majestic movement of stars, of vast clouds of gas, and of fine, interstellar dust, as they weave their way within its sweeping, spiral arms, through the discerning gaze of powerful and ever-advancing telescopes. The intricate and magnificent structure of Andromeda becomes strikingly clear, a revelation unfolding before our very eyes. Its glowing, expansive disk stretches with an ethereal beauty across the deep tapestry of the night sky. Within this luminous expanse, dark, serpentine lanes of dust cut deeply and dramatically through what appear as shimmering rivers of starlight, each gracefully spiraling inward toward the galaxy's dense and ancient core. Every single image captured, every photon gathered, offers us a precious, a fleeting glimpse into a familiar, yet grander, sense of cosmic order, a structure shaped and sculpted on an almost unimaginable and truly majestic scale. Andromeda, in its silent grandeur, acts as a profound and luminous mirror, reflecting back to us a potential vision of what our own home galaxy might appear like to hypothetical observers situated at vast distances far across the universe. Its remarkable nearness, its almost palpable presence in our cosmic neighborhood, makes it one of the most thoroughly and extensively examined objects within the entire realm of modern astronomy. It stands as a living, breathing example, a dynamic testament to the intricate ways in which galaxies grow, how they interact in slow gravitational balance, and how they gracefully and perpetually evolve across the immense, stretching canvas of cosmic time. Within its soft and ancient light, we perceive not merely a neighboring system, but also a profound vision of our own distant future, a cosmic narrative, elegantly written and silently inscribed across the vast and eternal canvas of the night sky. Deep inside Andromeda's immense and gracefully winding spiral resides an estimated, staggering trillion individual suns. Each of these stars, a unique, luminous entity, burns with its own distinct and radiant intensity, its own specific hue, and its own gentle but unwavering stellar rhythm. These countless stars, these myriad points of light, fill every conceivable region of the expansive galaxy. They populate the dense central bulge, a crowded hub, packed tightly with ancient, golden suns, and they also extend into the sweeping and elegant spiral arms, those grand, curving structures that reach outward, like cosmic tendrils, into the quiet and profound darkness. Some of these stars are truly massive, brilliant blue giants, whose fierce and short-lived existences culminate in spectacular supernova explosions, events that majestically seed the surrounding interstellar space with precious and heavy elements. Others, at the opposite end of the stellar spectrum, are tiny, faint red dwarfs, which burn dimly, almost imperceptibly, yet steadfastly, destined to shine for trillions of years into the far, distant future. Collectively, these innumerable stars, these varied points of light, orchestrate and create a luminous power, so incredibly potent, so immensely bright, that its soft, unwavering glow can be seen and perceived across the staggering distance of 2 million light-years of what appears as utter and profound emptiness. This enormous stellar population, this vast assembly of suns, bestows upon Andromeda both its profound and inescapable gravity and its undeniable, majestic grandeur. If even a minuscule percentage, a tiny fraction, of these countless stars were to host planetary systems, then the sheer number of worlds that might exist within that single grand galaxy would stretch far beyond the wildest reaches of our human imagination. Such a possibility suggests the potential presence of more habitable worlds, more quiet refuges for life to emerge than there are grains of sand scattered across every single beach on our entire Earth. Under the right, and often rare, celestial conditions, the Andromeda galaxy can be perceived by the naked eye from our own planet Earth. On a night that is perfectly clear, without the obscuring presence of the moon's light, and far, far removed from the intrusive glare of artificial city lights, the Andromeda galaxy, with its subtle charm, will reveal itself to anyone who possesses the patience and the quiet curiosity to carefully look upward. It manifests as a small and delicate misty oval, a gentle blur, within the familiar constellation that bears its name, Andromeda. This delicate shimmer, this soft, glowing patch, is not a mere trick of vision, not a figment of our tired eyes, but rather the incredible, combined luminosity, the collective light of over 1 trillion distant stars. For the ancient observers, for those who gazed at the heavens in epochs long past, this faint presence was an enduring mystery, a ghostly cloud that seemed to be neither a distinct star nor a familiar planet, existing quietly on the very edge of their cosmic awareness. It was only with the groundbreaking advent of optical telescopes that humanity began to truly glimpse its profound and majestic nature, slowly discovering that this ethereal blur was not, in fact, a mere cloud of gas and dust, but an entire, vast galaxy, a colossal island universe situated far beyond the confines of our own. When you manage to find it with your own unaided eyes, you are witnessing light, a stream of ancient photons that commenced its immense journey millions of years before the very dawn of written human history. You are, in that quiet moment, looking across both the vastness of space and the stretching tapestry of deep time itself, forging a silent and profound connection with the very same glow that was observed and contemplated by countless generations of stargazers long before your time. For centuries, a long and winding epoch, astronomers held a firm belief, a widely accepted notion, that the Andromeda galaxy was nothing more than a comparatively small and relatively insignificant nebula, a cloud of gas or dust, existing entirely within the luminous boundaries of our own Milky Way. Early, rudimentary telescopes could only reveal a faint and hazy patch of light, an indistinct blur, which led early observers to the logical, though ultimately incorrect, conclusion that it must surely be a mere cloud of cosmic gas or fine, interstellar dust. Throughout the 17th and 18th centuries, this mysterious object was universally known as the Andromeda Nebula, one among many fuzzy and enigmatic celestial forms meticulously catalogued by those pioneering early stargazers. That prevailing belief, that widely held conviction, persisted stubbornly until the pivotal decade of the 1920s. It was then that Edwin Hubble, a visionary astronomer, utilized the immense power of the 100-inch Hooker telescope, situated at the Mount Wilson Observatory, to conduct a much closer, a far more detailed and penetrating study of this enigmatic haze. Deep within that ethereal blur, that seemingly uniform mist, he made an astonishing discovery. He found a special and profoundly significant kind of star, known to astronomers as a Cepheid variable. These remarkable stars possess a unique characteristic: their rhythmic and predictable brightening and subsequent dimming reveals, with an exquisite precision, their true intrinsic distance. Hubble's meticulous calculations, based upon these celestial beacons, demonstrated, beyond any shadow of a doubt, that Andromeda lay incredibly far, immensely distant, far outside the established confines of our own home galaxy, millions of light years away, in the silent, intergalactic void. This singular discovery, this scientific revelation, was nothing short of revolutionary, a true paradigm shift in humanity's understanding of the cosmos. It undeniably proved that the universe, the entire known expanse of existence, was far, vastly larger than anyone had ever previously dared to imagine, a boundless realm filled with countless galaxies, beyond any easy human enumeration. The Andromeda Nebula, as it had been known, was reborn, transformed into the Andromeda Galaxy, and with that profound insight, humanity's grasp of the universe's true scale changed forevermore. When we direct our gaze, our quiet, contemplative attention, towards the luminous presence of the Andromeda Galaxy, we are not, in that very moment, observing it as it dynamically exists in its absolute present. Instead, our eyes, our instruments, are witnessing it as it appeared in a distant epoch, more than 2 million years, in the vast, unfolding tapestry of the past. Every individual particle of light, every single photon, that after its immense journey finally reaches and registers upon our sensitive eyes, commenced its incredible voyage long, long before the first members of the human species began their slow and tentative walk upon the ancient and still forming surface of Earth. That ancient light, those tireless photons, crossed the cold and silent and immeasurable gulf that lies between galaxies, carrying within their essence the indelible record, the quiet history of ancient suns. Some of those stars, whose light we now see, may, in their own cosmic time, have already faded, their brilliance extinguished, or perhaps they have dramatically exploded in spectacular supernovae, or even transformed themselves into the dense remnants of white dwarfs, or the profound singularities of black holes. Yet, despite their celestial fates, their enduring glow continues its onward journey, its undisturbed passage through the deep. Observing Andromeda, therefore, is akin to gazing directly through the very fabric of time itself. The soft light that now gently enters our powerful telescopes began its remarkable voyage when the distant ancestors of modern humans were meticulously shaping rudimentary stone tools and silently watching the flickering flames of distant primordial fires upon the vast and ancient plains of Africa. Each singular observation, every focused study of Andromeda is consequently both a rigorous and profound scientific act and simultaneously a moment of quiet and deeply personal connection to the immeasurable depths of the cosmic past. Its enduring radiance, its gentle, unwavering luminescence is a timeless message, a profound dispatch from the very heart of history itself, arriving, entirely unchanged, across the vast and silent corridors of countless ages. Though the Andromeda Galaxy appears serenely still and utterly calm within the quiet tableau of the night sky, it is, in its true, dynamic nature, actually racing with an astonishing velocity directly toward us. Its approach speed is truly remarkable, exceeding 200 kilometers every single second. Astronomers, with their keen insight and precise instruments, have successfully detected this relentless motion by carefully studying the light that is emitted from its countless stars. That particular light, as it reaches us, is ever so slightly and subtly shifted towards the blue end of the electromagnetic spectrum, a phenomenon known as blue shift. This delicate spectral signature serves as an undeniable indicator, a clear cosmic sign that the galaxy is indeed steadily moving closer to our own. This specific phenomenon of blue shift is quite unusual among the vast majority of observed galaxies, since most are actually receding, moving away from us, as the universe itself continues its grand and ongoing expansion. Andromeda, however, stands as one of the very few celestial systems that is heading directly and unequivocally toward our position, drawn irresistibly by the immense and profound gravitational pull that exists between our two magnificent and massive galactic systems. This gradual approach, this cosmic convergence, is entirely invisible to our unaided eyes, unfolding slowly and majestically across billions of years. Yet, its progress is utterly relentless, an unstoppable drift across the cosmic ocean. Nothing, it seems, can halt this predetermined celestial dance, this slow but certain cosmic drift, which has already been indelibly written into the very fabric, the fundamental motion of space itself. Within this quiet but unwavering advance, we can perceive not only a glimpse of the distant future of our own galaxy, but also the slow and intricate choreography of gravity, the fundamental force that gracefully shapes the entire unfolding universe. Utilizing sophisticated and ever more precise space observatories, such as the venerable Hubble and the revolutionary Gaia, scientists have achieved a remarkable feat. They have meticulously measured Andromeda's motion, its subtle drift, across the vast expanse of the night sky with an astonishing and unparalleled precision. These extraordinary observations, these careful measurements, reveal an undeniable truth. Andromeda is not simply passing by our galactic neighborhood, but is instead irrevocably locked upon a direct and unwavering path straight toward our own Milky Way. Advanced computer simulations, with their immense processing power, are able to trace this precise trajectory far into the unimaginable reaches of the distant future. These simulations vividly demonstrate how the immense force of gravity will gradually stretch both galaxies into luminous and elegant tidal streams before they finally and majestically merge into one. The initial, closest encounter, the first gentle touch of these two titans, is projected to occur roughly 4 billion years from this current moment. This will be followed by a slow and graceful spiraling union, an immense cosmic dance that could potentially take billions more years to fully complete, to reach its final, harmonious form. During that immense span of time, the night skies of any surviving worlds, any planets still orbiting within these merging systems, will be utterly transformed. They will be filled with vast and shimmering arcs of starlight stretching majestically across the entire horizon. The meticulous mapping of this inevitable collision has bestowed upon humanity a unique vision, a profound glimpse into its own far future, a cosmic destiny, elegantly written and silently inscribed within the immutable laws of fundamental physics. It represents a quiet but absolutely certain fate, patiently awaiting its arrival on the grand and immeasurable time scale of galaxies. The eventual and majestic meeting of our Milky Way and the Andromeda galaxy will not unfold as a cataclysmic explosion, a sudden, violent burst of energy. Instead, it will be a slow and exquisitely graceful merging, a celestial ballet that will gently unfold across an immense span of billions of years. Their magnificent, spiral arms, those grand, curving structures, will begin to twist and stretch like long, luminous rivers of starlight as the irresistible force of gravity slowly and steadily pulls them closer together. The vast majority of individual stars within both galaxies will never, in all likelihood, directly collide. This is because the immense spaces that separate them are so truly vast, so incomprehensibly immense, that direct impacts are exceedingly rare. However, their orbital paths, their individual trajectories, will certainly shift and gracefully weave new and intricate patterns within the growing, combined system. Over the deep and stretching tapestry of time, the two distinct galaxies will gradually combine and coalesce into a single, enormous, and majestic elliptical galaxy. This new entity will possess a bright and incredibly dense core, surrounded by broad and softly diffused edges. From any hypothetical, surviving planet, the night sky would be utterly filled with a dazzling and awe-inspiring light as stars from both systems gracefully mingle and intertwine across the vast celestial heavens. This profound merging, this cosmic union, will mark the next and momentous chapter in the enduring life of our cosmos, transforming two great spirals into one single, shining whole, a luminous monument that will silently endure long, long after. The Milky Way's original and familiar shape has gently and irrevocably transformed. Astronomers, with their visionary insight, have already bestowed a poetic name upon the magnificent galaxy that will majestically emerge from the slow and graceful union of the Milky Way and the Andromeda galaxy. They have chosen to call it Milkomeda, a beautiful blend, a harmonious fusion of the two original names, a linguistic echo that perfectly captures the shared legacy, the combined heritage of both immense systems. This newly formed galaxy, this future cosmic entity, will most likely contain several trillion stars, an almost unimaginable multitude of individual suns. It will also stretch and span across hundreds of thousands of light years in its immense diameter. At its very heart, the supermassive black holes from both original galaxies will slowly and inexorably drift together, gradually spiraling inward in a profound and silent dance until they finally merge in an immense and truly spectacular release of cosmic energy. Milkomeda, in its ultimate form, will shine as a smooth and gracefully rounded galaxy, distinguished by a brilliant and intensely luminous central glow. To any distant observer, gazing from afar, it will present itself as calm and perfectly symmetrical, an elegant monument, a silent testament to the immense forces, the gravitational artistry that meticulously built it. Within its soft and ancient light will reside the combined history, the interwoven narratives of two majestic galaxies that once quietly faced each other across the deep and silent dark. It serves as a gentle but profound reminder that even within the quiet stillness of the vast and seemingly unchanging space, everything is perpetually in a state of motion, a continuous cosmic flow, and that nothing in this grand universe truly lasts unchanged forever. The Andromeda Galaxy, a truly magnificent presence in our night sky, is widely considered one of the largest spiral galaxies that has ever been meticulously and extensively. The Andromeda Galaxy, this magnificent entity, unquestionably and quite profoundly dwarfs our own Milky Way in its immense and sprawling physical size. When we gaze upon it through the discerning lens of a powerful telescope, the sheer, overwhelming vastness of Andromeda becomes an almost impossible, a truly challenging concept for the human mind to fully and adequately comprehend. It is an experience that stretches the very limits of our spatial imagination. This colossal and majestic system unfurls its sprawling, luminous disk, a grand, celestial canvas that stretches for an astonishing, a truly breathtaking distance of more than 220,000 light years from one delicate, whispering edge to the opposite, far-reaching boundary. To place this into perspective, this incredible measurement reveals that Andromeda's diameter is nearly twice the already immense width of our familiar and beloved Milky Way. Imagine, if you can, the sheer scale, the profound difference such a comparison implies. Our home galaxy, though vast and glorious, appears as a comparatively smaller jewel beside this true cosmic titan. Within its expansive and luminous embrace, Andromeda holds and nurtures an astounding population of over 1 trillion stars. 1 trillion individual suns, each a furnace of nuclear fusion, each radiating light across immense gulfs of silent space. This staggering number, this almost inconceivable multitude, far surpasses the estimated hundreds of billions of stars that quietly reside within our own galaxy. And beyond its brilliantly shining disk, beyond the visible and easily discernible spiral arms, Andromeda extends even farther into the quiet dark, enveloped by a faint, almost ethereal halo. This immense and largely unseen aura fades so gradually, so imperceptibly, into the truly vast and profoundly empty intergalactic medium, the silent space that lies between the galaxies themselves. It is a testament to its colossal mass, its undeniable gravitational dominion. If our human eyes were miraculously capable of perceiving the full and complete extent of Andromeda's soft and ancient glow, if its entire sprawling halo were visible to us, it would majestically appear several times wider than the familiar and beloved full moon that graces our night sky. Imagine the breathtaking spectacle, the awe-inspiring vista of such a sight. A luminous, diffuse presence, dominating the heavens, stretching from one horizon to the other, a silent, celestial archway of ancient light. This sheer unfathomable scale, this profound grandeur serves as a powerful and humbling reminder. It teaches us that galaxies, in their true, unveiled nature, are not mere tidy and neatly contained spirals of light, as we often imagine them. Instead, they are truly sprawling cosmic cities, immense, living entities, meticulously constructed from countless suns, from vast, glowing nebulae, and from intricate, mysterious clouds of invisible matter. They are vibrant and dynamic ecosystems of light and shadow, of creation and transformation. When we consider our own Milky Way in direct comparison to the overwhelming majesty of Andromeda, it evokes a quiet and perhaps a slightly wistful feeling. Our home galaxy, with all its splendor, seems almost like a smaller sibling, a younger but still cherished member, orbiting serenely within the same immense family of stars and galaxies. Both these cosmic titans, these twin spirals, are inextricably bound by the enduring and universal force of gravity. They are destined by the immutable laws of the cosmos to one day, in the far, distant future, meet and merge in a magnificent and truly awe-inspiring cosmic union, a slow, majestic embrace that will reshape the very fabric of our local universe. The notion of one galaxy so utterly dwarfing another is more than a simple comparison of physical dimensions. It speaks to a profound difference in sheer gravitational influence, in the total accumulated mass that each system commands. Andromeda's immense size, its staggering stellar count, and its vast, extended halo all contribute to its dominant pull, its undeniable presence within our local galactic group. This gravitational supremacy means that Andromeda acts as a kind of cosmic anchor, its powerful force, shaping the movements and the destinies of many smaller satellite galaxies that quietly orbit it like loyal and obedient attendants. Our own Milky Way, though a mighty spiral with its own retinue of dwarf companions, still feels, in this grand cosmic dance, the subtle, yet persistent tug of Andromeda's greater mass. This silent but powerful interaction has been unfolding for billions of years, a slow but inexorable bullet across the deep and silent void. To fully grasp the immensity of this difference, to truly internalize what it means for Andromeda to be nearly twice the diameter of the Milky Way, we must first quietly contemplate the very meaning of a light year. A light year, as you may know, is not a measure of time, but of distance. It represents the astonishing length that a single photon, a tiny packet of light, can travel through the utter vacuum of space in the span of one terrestrial year. And light is the fastest thing known in the universe. It races at approximately 300,000 kilometers per second. So imagine, if you can, this incredible speed sustained without interruption for an entire year. That distance, already vast beyond our daily experience, must then be multiplied by 220,000. The number that emerges from such a calculation is so astronomical, so utterly immense, that it defies our intuitive understanding of scale. It becomes a number that can only be expressed in the silent, abstract language of scientific notation. It is a distance that stretches the very fabric of our comprehension. Now, take that immeasurable length and consider that our Milky Way, itself a colossal structure, is perhaps 100,000 to 150,000 light years across. Andromeda, at 220,000 light years, is not just a little larger, not merely slightly more expansive. It is a truly different order of cosmic architecture. It suggests a longer, perhaps a more vigorous history of growth, a greater accumulation of stars, of gas, and of the mysterious dark matter that silently binds all galaxies together. This difference in diameter alone implies a vastly more intricate tapestry of stellar populations, of nebulae, of planetary systems, all woven together within its grand and luminous embrace. It is a testament to the universe's capacity for truly monumental scales. Furthermore, the sheer volume of space that Andromeda occupies is not simply double that of the Milky Way. Because galaxies are three-dimensional disks and halos, the volume increases exponentially with radius. So, a galaxy with twice the diameter actually contains many, many times more space, more potential for stars and systems than its smaller counterpart. This means that within Andromeda's boundaries, there is an almost unfathomable amount of cosmic real estate, room for quadrillions of potential worlds, each silently orbiting its own distant sun. It's a universe within a universe, a grander, more expansive domain than our familiar home. And then there is the number of stars. 1 trillion suns compared to our estimated 200 to 400 billion. This isn't just a larger number. It represents a profound difference in the density and the luminosity of the galactic core and the richness of the spiral arms. 1 trillion stars means a greater collective output of light, a more intense and shimmering glow that radiates across the vast intergalactic distances. It means more stellar nurseries, more vibrant regions of star formation, continually breathing new life, new light into the galaxy. It means a greater diversity of stellar types, from the most massive and brilliant blue giants to the most ancient, and faint red dwarfs, each contributing to the galaxy's overall grand symphony of light and energy. Each star, a unique story, a burning narrative of cosmic existence. Consider the potential for life. If our galaxy, with its hundreds of billions of stars, is thought to potentially harbor millions of habitable worlds, then a galaxy with 1 trillion stars offers an almost limitless, a truly mind-boggling number of possibilities. The sheer statistical chance of life emerging and evolving in countless forms across untold worlds within Andromeda becomes a concept that fills the mind with both wonder and a quiet sense of overwhelming scale. Each star, a silent beacon, potentially surrounded by its own family of planets, some perhaps green and blue, like our own, some utterly alien, and beyond our current power of imagination. The thought alone is enough to make one softly and gently drift into contemplation. Andromeda's faint halo, this ethereal, almost ghost-like extension, is another key to understanding its immense scale. While the visible disk, with its brilliant stars and glowing nebulae, is already colossal, the halo stretches even further, far beyond what our eyes can directly perceive. This halo is not empty space. It is a vast, diffuse envelope composed primarily of tenuous gas of scattered, individual stars, many of them ancient and gravitationally unbound from smaller, absorbed galaxies, and most significantly, of the mysterious and unseen dark matter. This dark matter, this invisible scaffold, forms the vast majority of Andromeda's total mass, and its gravitational pull extends for millions of light years, fading gradually into the truly intergalactic void. It is this immense, invisible structure that truly elevates Andromeda's status from merely a large galaxy to a dominant and colossal presence within our cosmic neighborhood. It is the unseen power that underpins its visible majesty. The idea that if its full extent, its entire glowing halo, were visible to our eyes, it would appear several times wider than the full moon, is a truly profound thought experiment. Imagine gazing up at night and seeing not just a faint smudge, but a vast, luminous cloud, a shimmering expanse that fills a significant portion of the entire sky. It would stretch from one horizon to another, a gentle but undeniable presence, a cosmic arch of ancient light. The moon, our familiar companion, appears about half a degree wide in the night sky. So, if Andromeda was several times wider, it would be a truly breathtaking spectacle, a continuous, luminous river of stars and gas that would perhaps cause us to pause and simply marvel at the sheer, unimaginable scale of the universe. It would be a constant, visible reminder of the immensity that surrounds us, a silent, glowing testament to cosmic grandeur. This sheer and overwhelming scale, this profound difference in size, serves as a constant reminder, a gentle whisper from the cosmos itself. It reminds us that galaxies in their true and unvarnished nature are not the simple and tidy spirals of light that we often envision in our diagrams and simplified models. Instead, they are dynamic and sprawling cosmic cities, vast and intricate ecosystems made up not just of countless suns, each burning brightly, but also of immense, glowing nebulae where new stars are slowly forming, and of intricate and mysterious clouds of invisible matter, dark matter, which provides the gravitational scaffolding that holds these immense structures together. They are alive, with motion, with creation, and with the slow, unfolding dance of cosmic evolution, each a unique and complex entity, breathing and transforming across billions of years. The comparison of our Milky Way to Andromeda as a smaller sibling is a poetic and insightful way to understand their relationship. It suggests not a rivalry, but a familial bond, a shared origin, and a common destiny. Our galaxy, though still immense and filled with wonders, takes on a more modest, a more humble role when viewed alongside its larger and more massive cosmic sister. Both galaxies are inextricably bound by the invisible yet undeniable chains of gravity. They exist within the same local group, a small cluster of galaxies drifting together through the vastness of the universe. And they are, as the cosmic laws dictate, destined to one day, in the far distant future, meet and eventually merge into a single, magnificent, and unified cosmic entity. This union, this graceful embrace, will be a truly breathtaking event, a slow but majestic transformation of two grand spirals into something entirely new, something even more immense and luminous than either could be alone. It is a future already written in the quiet dance of gravity and time. The implications of Andromeda's colossal mass are far-reaching and profoundly significant for the dynamics of the entire local group of galaxies. Its immense gravitational field, its powerful and pervasive influence, extends far beyond its visible boundaries, reaching out like an unseen hand to gently tug and pull upon all the other members of this galactic family. It is the dominant gravitational force, the silent patriarch or matriarch of our local cosmic neighborhood. This dominance is not merely a matter of philosophical contemplation. It is a measurable force, a constant and undeniable influence that shapes the orbits, the trajectories, and ultimately, the destinies of all the smaller galaxies that quietly drift around it and even upon our own Milky Way. The very fact that Andromeda is moving towards us, rather than receding, like most other galaxies, is a direct consequence of this immense and irresistible gravitational pull, a testament to its profound cosmic authority. It is a force that cannot be ignored, a silent but powerful sculptor of galactic evolution. From a historical perspective, it is fascinating to consider how early astronomers, those pioneering stargazers, might have reacted if they had possessed the instruments and the knowledge to truly grasp Andromeda's monumental scale. For centuries, it was merely a faint smudge, a nebula within our own galaxy, a small cloud among many. The revelation of its true, colossal nature, its status as a separate and far grander galaxy, would have been an utterly mind-bending and transformative moment. It would have reshaped their entire worldview, their understanding of the universe's limits and our place within it. The very idea that there existed a city of stars, twice the size of our own, with 1 trillion suns, just beyond our visible reach, would have been a dizzying thought, an expansion of reality that would have echoed through every scientific and philosophical discourse of their time. It would have been a truly humbling and awe-inspiring discovery, a testament to the universe's unending capacity for surprise and for grandeur, the sheer energy and light output of a galaxy that is twice our size and contains roughly 2.5 times the number of stars is another aspect of its profound difference. 1 trillion suns, each radiating light and heat and energy across the vastness of space, creates a collective luminosity that is truly astounding. This means that Andromeda is not just physically larger, but also a far brighter beacon, a more intense source of cosmic illumination than our own Milky Way. Its light, though dimmed by the immense distance it travels, still carries the signature of this powerful collective brilliance. This greater energy output also implies a more active and dynamic internal life. More supernova explosions, more energetic stellar winds, more vigorous cycles of gas and dust being recycled and transformed into new generations of stars. It is a galaxy that pulses with a grander, more powerful rhythm, a more intense, cosmic heartbeat that resonates across millions of light years. The internal diversity within Andromeda is also amplified by its sheer size. More space and more stars naturally lead to a greater variety of phenomena and conditions. Imagine the countless nebulae, each a unique sculpture of gas and dust. The immense star clusters, both young and old, the varied types of planetary systems that must exist within its trillion stars. The larger scale allows for more extreme environments, more subtle variations, and a greater complexity in the distribution of gas and dust, and the patterns of star formation. It means a more intricate web of dark matter, a more diverse population of rogue planets drifting between its suns. Andromeda, in its immensity, is a truly comprehensive laboratory for stellar and galactic evolution, a place where almost every conceivable cosmic process is likely unfolding in some quiet corner of its vast domain. Its sheer size is not merely a number, but a promise of unending discovery and profound complexity. Consider the journey of a single photon as it begins its life within one of Andromeda's outermost stars. It has to travel, not just across the immense expanse to reach us, but first it must traverse the vast internal distances within Andromeda itself. From the very edge of its sprawling disk to its brilliant core, a photon might spend tens of thousands of years just navigating the internal structure of the galaxy, bouncing off dust grains, being absorbed and re-emitted before it even begins its 2 million-year voyage to our Milky Way. This internal travel time, this immense scale within the galaxy itself, further highlights the profound difference in size between Andromeda and a smaller system. It is a journey within a journey, a testament to the unimaginable distances that light itself must cover. The larger size of Andromeda also means that it has likely accumulated more of its smaller neighbors over cosmic time. Galaxies grow through a process often described as galactic cannibalism, where larger systems gravitationally absorb and incorporate smaller ones. Andromeda, being the largest in our local group, has undoubtedly devoured many dwarf galaxies in its long history. These past mergers, these quiet acts of cosmic consumption, have contributed to its immense mass, its extended halo, and the complex and warped structure of its disk. The faint streams of stars that we observe in its outer regions are the ghostly remnants, the silent echoes of these past meals. These absorbed systems, their stars now, are part of Andromeda's growing tapestry. So its size is not just an inherent property, but a record, a living history of its interactions and its growth over billions of years. It is a story written in light and shaped by gravity. The very concept of Andromeda's scale challenges our human-centric understanding of big. On Earth, we consider continents or oceans to be vast. In our solar system, the distance to Jupiter or Saturn is immense. But galaxies, and especially one as colossal as Andromeda, operate on a scale that truly breaks our terrestrial conceptions. It forces us to expand our minds, to stretch our imagination, to embrace numbers and distances that are almost beyond our ability to visualize. It is a humbling exercise, a profound meditation on the universe's boundless immensity. To contemplate Andromeda in its full grandeur is to recognize the insignificance of our everyday concerns, and to gain a quiet but profound perspective on our place within the cosmic design. We are but a speck on a speck within an infinitely sprawling landscape. The gravitational pull exerted by Andromeda, due to its monumental mass, also affects the very expansion of the universe in its immediate vicinity. While the universe, on a grand scale, is continually expanding, pulling most galaxies away from each other, the immense gravity between Andromeda and the Milky Way is strong enough to overcome that universal expansion, at least locally. This is why they are drawing closer, a unique dance among the receding multitudes. This local gravitational dominance is a direct consequence of Andromeda's size, its immense reservoir of mass, both visible and dark. It is a silent testament to the power of accumulated gravity, a force that can, even locally, defy the very expansion of space itself. It creates a region, a small pocket, where the universe is not quite behaving as expected, a testament to the extraordinary nature of these galactic giants. The presence of such a vastly larger neighbor also has implications for the future evolution of our own Milky Way. As we approach Andromeda, our galaxy will not remain unchanged. The gravitational tides exerted by Andromeda will begin to stretch and distort our own spiral arms, pulling stars and gas into new configurations. Our galaxy's disk may even warp and ripple in response to the immense external force. In a way, our Milky Way is already under the subtle influence, the distant but persistent tug of its larger sibling. This interaction, this cosmic dance, is not just about a future collision, but an ongoing and continuous process of gravitational shaping that has been occurring for billions of years and will continue for billions more. The larger galaxy inevitably dictates much of the choreography of this immense and beautiful celestial ballet. Andromeda's larger size also hints at a potentially older, or at least a more consistent, history of star formation. A galaxy that has accumulated more mass and more stars might have begun its star-forming activities earlier in the universe's history, or maintained a higher rate of creation over longer periods. Its central bulge, packed with ancient yellow and red stars, suggests a very early and prolific period of star birth that has since quieted. The sheer volume of gas and dust it has managed to retain and process into new stars over cosmic time is directly related to its gravitational strength and thus its overall size. It is a galaxy that has been a cosmic engine of creation on a grander scale for a longer duration than many of its peers, a testament to its enduring vitality and its continuous growth. The sheer scale of Andromeda also means that it contains a wider spectrum of elemental compositions across its various regions. With more stars, living and dying over billions of years, there have been more supernova explosions, more opportunities for the interstellar medium to be enriched with heavy elements. These elements, forged in the hearts of massive stars, are the building blocks for rocky planets and ultimately for life itself. So, a larger galaxy, like Andromeda, might, in theory, offer a greater abundance of these crucial ingredients spread across its vast expanse. This chemical enrichment, this cosmic alchemy, is a slow but powerful process that unfolds over geological and galactic time scales, and Andromeda, with its monumental size, has been a truly prodigious alchemist, transforming primordial hydrogen into the complex chemistry of the universe. The knowledge of Andromeda's immense size also transforms our understanding of the island universe concept. When astronomers first realized that Andromeda was a separate galaxy. They were stunned by the idea of another island of stars beyond our own. But to then discover that this neighboring island was not just separate, but significantly larger, more populous, and gravitationally dominant than our own, deepened the profound implications. It meant that our Milky Way was not necessarily the largest or the most central or the most significant of these cosmic islands. It introduced a new level of cosmic hierarchy, a greater diversity in the galactic landscape. It broadened the definition of what a galaxy could be and what it could contain, pushing the boundaries of our imagination even further into the boundless depths of space. The fact that Andromeda's disk stretches over 220,000 light years is a monumental figure that we must gently unpack. If you could travel at the speed of light, it would take you more than 2 centuries to cross from one side of Andromeda to the other. Think of all the history, all the civilizations, all the changes that could occur on a planet during 220,000 years. This is the internal scale of Andromeda. It is a journey so vast that human lifetimes are utterly insignificant in comparison. A single beam of light, beginning its journey from a star on one side of Andromeda, would finish its traverse of the galaxy, only to then begin its 2 million-year voyage to our Earth. This concept of internal scale is crucial to truly appreciating the meaning of its immense size. It is a measure of deep time and vast distance, intertwined. Andromeda's larger diameter and its greater mass also contribute to its potential for housing a more complex and extensive network of globular clusters. These ancient, spherical collections of hundreds of thousands of old stars are often found orbiting in the halos of large galaxies. Andromeda is known to possess a truly impressive number of these clusters, some of them among the largest and most massive ever discovered. These globular clusters are like time capsules, relics from the early universe, preserving the oldest stars and providing clues to the galaxy's formation. A larger galaxy with more gravitational reach can capture and retain a greater number of these ancient relics, adding to its historical richness and its scientific value. They are silent witnesses to billions of years of cosmic history held in Andromeda's vast and ancient embrace. The comparison of Andromeda as a sprawling cosmic city is a particularly apt metaphor. Imagine not just a single, dense metropolis, but an entire continent, or even a world-spanning urban sprawl where each star is a neighborhood, each nebula a park or a factory, and the dark matter, the invisible infrastructure that holds the entire system together. Within this vast city, there would be regions of intense activity where new stars are being born, like bustling downtowns, and quieter, older regions where stars burn steadily, like ancient, historic districts. There would be streams of, at the very heart, the luminous core of the Andromeda galaxy, resides a glowing and remarkably compact region. This central expanse burns with an intensity, a radiant brilliance, that surpasses almost every other location within its vast and sprawling disk. The light emanating from this dense hub is soft and possesses a golden hue, a warm amber glow. It represents the collective and combined radiance of countless stars, an immense multitude that have quietly burned for billions of years, their ancient fires sustaining this central luminosity. The majority of these stellar inhabitants, these countless suns, are significantly older, more venerable than our own familiar and beloved sun. They are smaller and burn with a steady, unwavering calm, their nuclear fuel, slowly and gracefully fading over immense stretches of cosmic time. These ancient stars, these quiet, golden beacons, are packed together with an astonishing density within this central region. So tightly are they clustered that in some localized areas, they are separated by only a fraction of a single light year. Imagine the crowded heavens, the breathtaking proximity of so many suns, each casting its light upon its immediate neighbors. From this incredibly dense and bustling hub, this luminous heart, their combined light embarks upon its immense journey, traveling for more than 2 million years, before it finally and gently reaches our telescopes here on Earth. The distinctive and pervasive golden color of Andromeda's core serves as a clear signal, a silent indicator to astronomers. It tells them that this central region is predominantly home to an older, a more mature stellar population. Here, the frantic and energetic birth of new stars, a process so common in the spiral arms, has long since quieted and subsided into a more serene and stable existence. In a profound and almost poetic sense, Andromeda's glowing heart can be viewed as a living fossil, a remarkably preserved remnant, a shimmering echo of its very earliest days, its primordial beginnings. It continues to glow quietly, with an ancient, unwavering luminosity, its light traversing the vast corridors of countless ages to reach us, a silent testament to the galaxy's long and majestic history. This central golden glow is more than just pretty light. It is a window, a cosmic portal, into the deep past, revealing the conditions and the stellar populations that characterized the galaxy billions of years ago, when the universe itself was still young and rapidly evolving. The density of stars in this central region is almost beyond our ordinary comprehension. To say they are only a fraction of a light year apart means that if you were to stand on a hypothetical planet within this core, the night sky would not be dominated by distant points of light as it is from Earth. Instead, it would be a continuous blaze of suns, each a brilliant orb, filling a significant portion of the heavens. The concept of night itself might be utterly redefined, as the combined light of so many close stars would create an eternal twilight, a perpetual glow that never truly dims. This crowded and intensely luminous environment would be a place of unimaginable energies and profound gravitational interactions, a true stellar metropolis at the peak of its ancient splendor. The golden hue is not arbitrary. It is a direct indicator of stellar age. Young, massive stars burn hot and blue, their fierce energy expending their fuel quickly. But older stars, like our own sun, as they approach or enter their red giant phase, or simply burn more gently as less massive, long-lived stars tend to glow in warmer colors, yellows, oranges, and reds. The overwhelming dominance of these older, cooler stars in Andromeda's core paints it with this distinctive and serene golden light. It is the color of cosmic maturity, of slow, patient burning, a contrast to the vibrant and energetic blues that sparkle in the galaxy's younger spiral arms. This color difference is a visual timeline, a silent map of Andromeda's evolution from its fiery birth to its current majestic age. The idea of the core as a living fossil is a powerful metaphor. It suggests that this region has, in many ways, preserved the conditions and the stellar populations that were prevalent in the galaxy's earliest epochs. While the outer regions and the spiral arms have undergone continuous cycles of star formation and dramatic change, the core has settled into a more stable and enduring state. It is a testament to the long, term stability, of massive galactic structures, a place where time seems to flow with a different rhythm, a more ancient and unhurried pace. The light we see from this fossilized heart is a direct link to the universe as it was billions of years ago, a tangible piece of cosmic history delivered to our eyes by photons that have journeyed for eons. It's a whisper from the deep past, a story told in golden light. The sheer number of ancient stars crammed into this relatively small volume of space also means that their combined mass exerts an immense gravitational pull. This is the force that helps to shape and stabilize the entire galactic structure, keeping the inner regions tightly bound and influencing the orbits of stars throughout the central bulge. It is a region where gravity is particularly strong, a deep well of cosmic attraction that anchors the swirling vastness of the galaxy around it. This powerful gravitational field is also directly linked to the presence of the supermassive black hole that is believed to reside at the very center of this dense and ancient core. The stars, in their multitude, are both the source and the subjects of this profound and enduring gravitational dance. To imagine the journey of light from this core is to truly contemplate deep time. A photon born in the core 2 million years ago would have begun its journey when early hominids were just starting to walk upright on Earth. It would have passed through the rise and fall of countless species, the slow geological changes that shaped our planet, the development of language, of civilization, of all recorded history. And yet, that light, unaltered, unhurried, continues its passage until it finally reaches our instruments, a timeless message from an epoch that is almost unimaginable to us. It is a profound testament to the universe's patience and to the enduring power of light itself as a messenger across the ages. The subtle, yet profound, difference in star formation rates between the core and the spiral arms is a key aspect of galactic evolution. In the core, most of the gas and dust, the raw materials for new stars, was used up billions of years ago in a frantic burst of early star birth. What remains is a stellar population that has largely settled into a serene and mature state. The stars here are like wise elders, their fiery youth long behind them. In contrast, the spiral arms are regions of ongoing and vigorous creation where fresh gas and dust is continually compressed and ignited into brilliant, young blue stars. This contrast, this duality between the ancient heart and the youthful, sparkling arms tells a complete story of a galaxy's life cycle, from its energetic beginnings to its mature and enduring present. It is a cosmic narrative unfolding in light and in color. The sheer density of stars in the core also means that stellar interactions, though still rare on an individual star basis, are more common than in the sparser outer regions. Stars might pass closer to each other, their gravitational fields gently tugging and altering each other's orbits. Binary systems might be more prevalent, and the conditions for the formation of exotic objects like X-ray binaries involving black holes or neutron stars are enhanced. It is a dynamic and crowded environment where the collective gravity of billions of suns creates a complex and intricate dance, a constant but gentle ballet of cosmic motion. This density is a defining characteristic of the core, a signature of its long and tumultuous past and its current, serene stability. The golden light from Andromeda's core is not just beautiful, it is also rich in scientific information. Spectroscopic analysis of this light allows astronomers to determine the chemical composition of these ancient stars. They can measure the abundance of heavy elements, or the lack thereof, which provides clues about the galaxy's early history and the conditions of the primordial gas from which these stars first formed. Stars in the core are generally metal poor, meaning they contain fewer elements, heavier than hydrogen and helium, compared to younger stars. This is because they formed before many generations of supernovae had enriched the interstellar medium with these heavier elements. So, the golden glow is a chemical signature, a genetic code written in starlight that tells us about the very first epochs of creation within the Andromeda galaxy. It is a deep and ancient truth expressed in light. The stability of this central region, despite its immense density, is a testament to the long-term gravitational equilibrium within a mature galaxy. Once the initial violent period of star formation has subsided and the gas has been largely consumed, the remaining stars settle into stable orbits around the central mass and the supermassive black hole. This creates a kind of cosmic calm, a serene stability that can endure for billions of years. The core becomes a slow and majestic clock, ticking away the eons, its golden light, a constant presence in the deep and silent dark. It is a place where the frantic pace of youth has given way to the quiet and enduring wisdom of age, a profound example of galactic maturity. Even though star formation has largely ceased, in the core, the stars that remain continue to evolve. Some will slowly and quietly become white dwarfs, their nuclear fires extinguished, their cores gently cooling over trillions of years. Others, more massive ones, might eventually collapse into neutron stars or even stellar mass black holes, adding to the hidden and invisible mass of the central region. So, even in its serenity, the core is not static. It is a place of slow but continuous evolution, a silent transformation of stellar remnants, a testament to the inexorable march of cosmic time. The golden glow, therefore, is not just a snapshot, but a continuous and evolving story of ancient stars living out their long and final acts in the grand cosmic drama. The profound beauty of Andromeda's glowing core lies not just in its visual appeal, but in the deeper meaning it conveys. It is a symbol of endurance, of stability, and of the long and patient processes that shape the universe. It reminds us that even in the midst of expansion and change, there are regions of profound continuity, places where the ancient light continues to shine unwavering across the ages. It is a testament to the power of countless individual suns, each contributing its small part to a collective brilliance that transcends its own finite life. The golden heart of Andromeda is a silent and majestic beacon, a source of wonder and quiet contemplation in the endless and beautiful night sky. Astronomers, with their keen insights and their powerful instruments, have diligently studied the very innermost regions of Andromeda's dense and luminous core. Through these meticulous investigations, they have successfully detected the presence of stars whipping around an unseen and incredibly massive object with truly astonishing and blistering speeds. This incredible and rapid orbital motion is so extreme, so utterly profound, that the only plausible explanation, the sole cosmic solution that accurately fits the precise observational data, is the undeniable existence of a supermassive black hole. This colossal entity, this gravitational behemoth, is believed to be millions of times more massive than our own familiar and beloved Sun. The gravitational pull exerted by this invisible giant is so immensely intense so overwhelmingly powerful that not even light itself, the fastest entity in the entire universe, can escape its relentless grasp once it crosses the black hole's fateful boundary, known as the event horizon. Around this profound singularity, countless stars, those ancient, golden suns, dance in incredibly tight orbits, performing a magnificent, gravitational ballet, a silent, celestial choreography that has been gracefully unfolding for billions of years. The immediate space surrounding this supermassive black hole is, in all likelihood, filled with swirling and turbulent disks of incredibly hot gas and fine interstellar dust. These superheated materials glow with an intense and brilliant radiance as they inexorably spiral inward, their destinies sealed towards the black hole's insatiable maw. Although this black hole remains entirely invisible to our direct gaze, its profound and undeniable presence can be meticulously inferred through the precise and rapid motion of the nearby stars. It can also be detected through the powerful and energetic radiation that is emitted by its intensely heated and swirling surroundings. It functions as a silent, yet incredibly powerful, engine of gravity, a cosmic orchestrator, shaping the very heart of the Andromeda galaxy and profoundly influencing the rhythmic motion of everything that gracefully orbits within its immense gravitational grasp. The discovery of this supermassive black hole was a triumph of observational astronomy, a testament to our ability to detect the unseen through its effects. We cannot directly photograph a black hole, for its very nature is to absorb light. But the gravitational signature it leaves on its stellar neighbors is unmistakable. The stars closest to the center are not just moving quickly, they are moving at speeds that defy the gravitational pull of merely a dense cluster of stars. The only explanation for such extreme velocities is the presence of an object with an immense and concentrated mass packed into a tiny volume, a supermassive black hole. The concept of stars performing a gravitational ballet around this hidden behemoth is both beautiful and scientifically precise. Each star is a dancer, its path dictated by the invisible maestro, the black hole. Their orbits are not chaotic but highly organized, a complex but stable system that has maintained its intricate pattern for billions of years. This ballet is a continuous performance unfolding over cosmic time, a silent demonstration of the fundamental laws of gravity at work on the grandest possible scale. It is a cosmic clockwork powered by an unseen engine. The swirling disks of hot gas and dust around the black hole are known as accretion disks. As matter spirals inward, it experiences immense friction and compression, heating it to millions or even billions of degrees. At these extreme temperatures, the gas emits powerful radiation across the electromagnetic spectrum, especially in X-rays and gamma rays. This glowing and energetic region is often the brightest part of a galaxy's core, even though the black hole itself is dark. It's a testament to the immense power that can be unleashed when matter falls into the deepest gravitational wells in the universe. This radiation is another indirect way we infer the black hole's presence, a luminous echo of its dark reality. The role of this black hole as a silent engine of gravity is central to understanding Andromeda's core. It doesn't just influence the stars immediately around it. Its immense mass contributes significantly to the overall gravitational field of the entire central bulge. It acts as a profound anchor, a central pivot around which the billions of stars in the core perform their slow and majestic orbits. This influence extends even farther, subtly affecting the dynamics of the inner spiral arms. It is a quiet but pervasive force, a gravitational heart that beats at the very center of the galaxy, determining much of its internal rhythm and its long-term stability. The existence of such a supermassive black hole is not unique to Andromeda. Almost every large galaxy, including our own Milky Way, is now believed to harbor one of these colossal gravitational sinks at its center. This suggests a fundamental connection between the formation and evolution of galaxies and the growth of their central black holes. They seem to co-evolve, their destinies intertwined from the earliest moments of the universe. Studying Andromeda's black hole, therefore, provides invaluable insights into this universal relationship, helping us to understand how these dark giants influence the cosmic environment on the grandest scales, and how they shape the very structures that fill our universe. The thought of an object so massive, so powerful, yet utterly invisible, is a profound concept that can inspire a quiet sense of awe and humility. It reminds us that much of the universe's most fundamental nature remains beyond our direct senses, hidden in the dark, or revealed only through the subtle but undeniable fingerprints they leave on the visible cosmos. Andromeda's central black hole is one of these great mysteries, a silent testament to the universe's capacity for extremes, a place where the laws of physics are stretched to their very limits, and where gravity reigns supreme. In absolute and profound darkness, it is a cosmic secret, slowly and gently unveiling itself through the language of light and motion. The sheer scale of millions of solar masses concentrated into a region smaller than our solar system is almost impossible to grasp. If our Sun were replaced by Andromeda's black hole, its gravitational influence would extend far beyond the orbit of Pluto, swallowing planets and altering the very fabric of our local space-time. This extreme density is what generates the incredible gravitational pull that we observe. It is a point of immense power, a singular anchor for billions of stars, a cosmic vortex at the heart of a colossal galaxy. To contemplate this hidden monster is to confront the raw, untamed power of the universe, a force that shapes and governs the grand architecture of galaxies with an unseen hand. The study of the dynamics around Andromeda's black hole also involves the concept of relativistic effects. While stars far from the black hole follow Newtonian orbits, those in its immediate vicinity experience space-time that is significantly warped and distorted by the black hole's gravity. Their paths are not simple ellipses, but complex, precessing orbits that provide further evidence of the black hole's extreme nature. This is where Einstein's theory of general relativity becomes essential to accurately describe the motions and the energies at play. So, Andromeda's core is not just a cosmic marvel, but a profound laboratory for testing the most fundamental theories of gravity and the structure of space-time itself. It is a place where the universe reveals its deepest and most intricate secrets. The potential for future mergers of this black hole with the Milky Way's central black hole is another fascinating aspect. When the two galaxies collide and eventually merge, their supermassive black holes will slowly and inexorably spiral towards each other. This grand celestial dance will release immense waves of gravitational energy rippling through the very fabric of space, time, a cosmic symphony of unimaginable power. Eventually, they will coalesce into an even larger, more powerful, supermassive black hole. at the heart of the new Andromeda galaxy. This future event, though billions of years away, is already written in the gravitational laws that govern these cosmic titans. Andromeda's black hole, therefore, is not just a present mystery, but a key player in the grand and unfolding drama of our galactic future. It is a silent but essential participant in the universe's eternal transformations. When astronomers, with their most advanced and highest resolution instruments, meticulously scrutinized the very innermost core, the absolute center of the Andromeda galaxy, they made a peculiar and quite unexpected observation. The light radiating from this intense region did not originate from a singular bright point, as might be anticipated. Instead, it seemed to emanate from two distinct and subtly separated luminous sources. This intriguing finding, this dual emission of light, prompted a compelling hypothesis, a fascinating theory among the scientific community. It led them to speculate that Andromeda might, in fact, host not one, but two supermassive black holes. These two colossal entities, if truly present, would be quietly orbiting one another, locked in an incredibly slow cosmic dance, a gravitational pas de deux unfolding over aeons. Such a celestial pair, two supermassive black holes, gracefully intertwined, would represent the ancient relics, the lingering remnants of a long-ago galactic merger. In the distant past, when the universe was younger, two ancient galaxies, perhaps smaller than the current Andromeda, would have inevitably collided. Their respective central black holes would then have begun a slow and inexorable spiraling path, drawing closer and closer to one another within the newly merged system. Over vast and immeasurable stretches of cosmic time, these two gravitational giants may continue to draw nearer, their immense masses releasing powerful waves of gravitational energy that subtly ripple through the very fabric of space-time itself. Eventually, in the far, distant future, they could, in a final, cataclysmic embrace, merge into an even larger, a truly colossal and singular black hole. If this captivating hypothesis, this idea of a hidden partnership deep within Andromeda's golden core, proves to be true, it offers us a profound glimpse, a unique preview into the potential future of our own home galaxy, the Milky Way. For our Milky Way also quietly harbors its own massive black hole, Sagittarius A, at its very center. This central giant may one day, in the unimaginably distant future, meet its Andromedan counterpart or counterparts in a similar, grand, and awe-inspiring cosmic embrace. The thought alone of such a dual system, a pair of gravitational titans silently orbiting in the heart of a galaxy, is enough to evoke a deep and quiet sense of wonder and cosmic contemplation. The initial observation of two distinct bright points was a subtle but powerful clue. It challenged the conventional understanding of galactic cores, which typically feature a single, dominant black hole. This anomaly, this unexpected duality, sparked intense investigation and creative theorizing among astronomers. The idea that these bright points could be the accretion disks around two separate black holes, each glowing fiercely as matter falls inward, provided a compelling explanation for the observed phenomenon. It suggested a more complex and dynamic central region than previously imagined, a testament to the universe's capacity for surprise and its intricate architecture. The concept of a gravitational dance between two supermassive black holes is truly mesmerizing. These objects, though invisible, would exert immense forces on each other, causing them to orbit a common center of mass. This orbit would be incredibly slow, unfolding over millions or even billions of years, as they gradually lose orbital energy through the emission of gravitational waves. Each pass, each subtle shift in their positions would send ripples through space-time like stones dropped into a cosmic pond. It is a dance of immense power and profound elegance, a celestial waltz performed in the deepest and darkest heart of a colossal galaxy. The hypothesis of these dual black holes as relics of a long-ago galactic merger is a key piece of the puzzle. Galaxies grow by merging with others, and when two galaxies, each with its own central supermassive black hole, collide and combine, their black holes do not immediately merge. Instead, they typically sink towards the center of the newly formed galaxy and begin to orbit each other in a binary system. This process can take a very long time, billions of years, as they shed orbital energy through interactions with stars and gas, and eventually through gravitational waves. So, the presence of two black holes in Andromeda's core would be direct evidence of a significant past merger event, a silent but profound scar of cosmic history etched into the galaxy's heart. The implications for our own galaxy's future are particularly striking. If Andromeda, which is destined to merge with the Milky Way, already contains a binary black hole system, then our future galaxy, Milkomeda, could potentially end up with not just 2, but 3, or even 4 supermassive black holes, all slowly and inexorably spiraling towards a grand final merger. This would create an incredibly dynamic and energetic core, a gravitational nexus of immense power. It's a thought that expands our understanding of galactic evolution and the ultimate fate of these colossal gravitational engines. Our own black hole, Sagittarius A, would become a participant in a much grander and more complex celestial dance. The release of waves of gravitational energy as these black holes merge is a phenomenon that scientists are now able to detect using advanced observatories like LIGO and Virgo. These gravitational waves are ripples in the fabric of space, time itself, predicted by Einstein, and only recently directly observed. While the merger of stellar mass black holes produces detectable signals, the merger of supermassive black holes would release gravitational waves of truly monumental and unprecedented power, waves that would literally shake the entire cosmos if they passed close enough. So, the slow dance of these hypothetical Andromedan black holes is a prelude to a cosmic crescendo, a silent symphony of gravity that will one day resound across the universe. The hidden partnership in Andromeda's core is a testament to the universe's capacity for complexity and for concealing its most profound secrets in plain sight. What appears to be a single, luminous point, when viewed with less powerful instruments, unveils a deeper, more intricate reality under the discerning gaze of cutting-edge technology. It reminds us that our understanding of the cosmos is always evolving, always deepening as we develop new ways to peer into its innermost workings. Each new discovery, each subtle clue, reveals another layer of the universe's astonishing beauty and its profound and enduring mystery. Andromeda's core, with its potential dual black holes, is a shining example of this endless journey of cosmic revelation. The notion of bar-similar cosmic embrace is a beautiful way to describe the eventual coming together of these gravitational giants. It's not a collision in the sense of two solid objects smashing into each other. Instead, it's a slow but irresistible gravitational dance where the objects gradually spiral inward, their immense masses eventually coalescing into a single, more powerful entity. This embrace is a testament to the elegance and the power of gravity, the force that governs the largest structures in the universe and shapes their ultimate destinies. It is a silent but profound cosmic event, a transformation that represents the culmination of billions of years of galactic evolution. Beyond the bright and familiar spiral disk of the Andromeda galaxy lies an immense and diffuse halo. This vast, ethereal envelope stretches far into the depths of surrounding space. It remains entirely invisible to our human eyes, as it is predominantly composed of incredibly thin gas, of sparsely scattered dust, and most significantly of the elusive and mysterious dark matter. This colossal halo extends for more than 1,000,000 light-years from the galaxy's central core. Such an immense reach makes it several times larger in sheer spatial extent than the entire visible portion of the galaxy itself. Within this truly immense and ghostly envelope quietly float ancient star clusters and delicate streams of stars, each a lingering trace, a celestial memory left behind by long vanished and absorbed galaxies. Scientists meticulously study this expansive halo by employing observations in ultraviolet and X-ray wavelengths. These advanced techniques allow them to trace the faint and subtle signatures of atoms that have been excited by distant starlight or by energetic processes within the halo itself. Though ethereal and largely unseen, this halo plays a crucially important role in Andromeda's overall structure and its long-term stability. It acts simultaneously as both a vast reservoir of cosmic material, a hidden well of gas and dust, and as a significant boundary, a defining edge that marks the true extent of Andromeda's profound gravitational influence. It is, in essence, the galaxy's ghostly aura, its silent but powerful embrace, unseen by direct light yet undeniably potent, gradually blending and softening into the intergalactic medium, the vast and empty space that quietly fills the immense gulf between galaxies. The fact that this halo is invisible to human eyes is a key aspect of its mysterious nature. It's not that there's nothing there. It's that the matter is so incredibly diffuse, so spread out, that it doesn't emit or reflect enough visible light for us to perceive it. Imagine a vast, transparent veil stretching for millions of light years, so thin that it's almost a perfect vacuum, yet still containing enough mass to this immense and ethereal halo. The vast, unseen envelope that surrounds Andromeda may in fact already be gently and subtly brushing against our own Milky Way. The two magnificent galaxies, our home system and its larger neighbor, Andromeda, are typically understood to be separated by an immense chasm of more than 2,000,000 light-years of what appears to be profound and utter emptiness. Yet, recent and highly sensitive observations have begun to suggest a truly fascinating possibility. They indicate that the outer regions of their respective halos, those sprawling, diffuse envelopes, are indeed already beginning to overlap. This remarkable finding, this subtle cosmic contact, implies that the two galaxies are no longer entirely distinct and isolated entities. Instead, they are already in a quiet and imperceptible form of direct communication, not through visible stars or brilliant light, but through the tenuous and incredibly sparse plasma and the ubiquitous and mysterious dark matter that silently envelopes each of them. It is as if two colossal and invisible atmospheres have, at long last, begun the slow and graceful process of merging long before the actual and more dramatic collision of the galaxies themselves becomes apparent. over immense stretches of cosmic time. This initial and subtle contact may steadily grow stronger, leading to a gradual and profound exchange of energy and of fundamental particles across the silent, intergalactic void. The very idea that our home galaxy, the Milky Way, is already, in some form of touch, even faintly, with another immense system, a cosmic neighbor, reshapes, in a profound way, how we typically imagine the fundamental structure of the cosmos. It clearly demonstrates that the perceived boundaries in the vastness of space are rarely sharp or definitively distinct. Instead, galaxies are revealed to gently blend and subtly influence one another, their gravitational fields intertwining long before the more dramatic and visually striking spectacle of a true and full-scale collision actually commences. They whisper their presence to each other through faint glows and subtle tugs that gracefully stretch across millions of light years. The concept of brushing against is a gentle but scientifically profound metaphor. It suggests the earliest stages of an interaction that will culminate in billions of years with a full galactic merger. Imagine two colossal, invisible clouds slowly drifting towards each other, their outer edges, the most diffuse parts, first making contact. This contact is not a violent impact, but a soft, almost imperceptible intermingling of the thinnest gases and the most elusive dark matter. It's a testament to the sheer scale of galactic halos, that they can extend so far as to bridge the immense gulf between two major galaxies. The overlap of these halos is a crucial discovery. It means that the gravitational influences of both galaxies are already directly interacting in the region where their halos meet. This interaction, though subtle, can have long-term consequences for the distribution of gas and stars in both systems. It might even gently stir the outer regions of our own galaxy, or Andromeda, in ways that we are only beginning to understand. The universe is not a collection of isolated islands, but a continuous, interconnected web, and this halo overlap is a vivid demonstration of that cosmic truth. The tenuous plasma that is part of these halos is incredibly diffuse, made up of ionized gas so sparse that it's almost a perfect vacuum. Yet, even in this extreme thinness, it carries energy and particles, and its collective mass contributes to the gravitational field. When these plasma clouds from both galaxies begin to intermingle, they can exchange heat and momentum, a silent transfer of cosmic energies across the void. This exchange is part of the slow, metabolic process of galactic evolution, where material is recycled and redistributed over immense timescales. It's a subtle breathing of the cosmos, a silent exhalation and inhalation of matter and energy. And then there is the dark matter, the most mysterious and pervasive component of these halos. Dark matter does not interact with light, but its gravitational pull is undeniable. The fact that the dark matter halos of Andromeda and the Milky Way are already overlapping means that the invisible gravitational structures that dominate both galaxies are now intimately connected. This has profound implications for the simulations of the future merger, as the dark matter will play a crucial role in guiding the gravitational dance of the visible stars and gas. It is the unseen hand that is already, gently but firmly, guiding the two galaxies towards their inevitable union. The overlap of these dark matter halos is perhaps the deepest and most fundamental connection between our two galaxies, a bond forged in the invisible but powerful fabric of gravity. The metaphor of two invisible atmospheres beginning to merge is particularly evocative. It suggests a gradual and gentle process, like two immense and ghostly clouds, slowly interpenetrating, their edges softening and blending into a single, larger entity. This is not a sudden event, but a slow unfolding transformation that takes hundreds of millions of years to become significant. It is a testament to the universe's immense patience and its capacity for gradual but profound change. The merging of these atmospheres is the first whisper of the future, a prelude to the grand symphony of the galactic merger. This initial and subtle contact is a key moment in the cosmic narrative. It marks the point at which the two galaxies cease to be truly separate and begin their long journey towards unity. Even before their visible disks begin to interact, their gravitational fields are already entangled, their invisible components already intermingling. This highlights the importance of studying the faint and diffuse outer regions of galaxies, where the most distant and subtle interactions first begin. These regions are the frontiers of galactic encounters, the places where the universe's grand choreography first becomes apparent. The exchange of energy and of fundamental particles across the void is a continuous process. Cosmic rays, high-energy particles, can travel through these overlapping halos, carrying energy and information from one galaxy to the other. Magnetic fields, though faint, can also connect the two halos, providing pathways for these particles. This exchange is a silent dialogue between the galaxies, a constant but imperceptible flow of cosmic material that slowly but surely blends their compositions and their energies. It's a subtle form of intergalactic communication, a language spoken in particles and fields rather than light. The profound implication that boundaries in space are rarely sharp or definitively distinct is a fundamental truth revealed by this discovery. We often draw clear lines on maps and in diagrams to separate one celestial object from another. But in the real universe, things are far more fluid, far more interconnected. Galaxies are not isolated islands, floating in empty space with clear edges. Instead, they are vast, diffuse entities whose gravitational and material influences gradually fade and blend into their surroundings. This understanding challenges our simplistic, geometrical notions of cosmic structure and replaces them with a more nuanced and organic view of the universe as a continuously interwoven fabric. The idea that galaxies whisper their presence to each other through faint glows is a beautiful and poetic way to describe these early interactions. The faint glows are the subtle emissions from the tenuous gas in the halos, excited by distant starlight or by the gentle shockwaves of intermingling plasma. These are not brilliant beacons, but incredibly subtle, almost imperceptible luminescences that can only be detected by the most sensitive and patient instruments. They are the first soft murmurs of a conversation that will, in billions of years, become a grand and roaring symphony of merging galaxies. It's a reminder that even the quietest corners of the universe are alive, with motion and with subtle but profound interactions. This discovery of overlapping halos also highlights the ever-evolving nature of astronomical research. For a long time, the space between galaxies was considered to be largely empty, a vast, featureless void. But with increasingly sensitive telescopes and new observational techniques, we are finding that even this empty space is filled with tenuous gas, with faint streams of stars, and with the pervasive dark matter. The universe is continually revealing new layers of complexity and interconnectedness, even in the regions we once thought we understood. Andromeda's halo and its interaction with our own is a prime example of this ongoing process of discovery, a testament to the universe's unending capacity for surprise. The implications for the future of our local group are significant. This early contact suggests that the merger between Andromeda and the Milky Way is not just a theoretical prediction based on current velocities, but a process that has already begun in its most subtle and diffuse forms. The galaxies are already partially intertwined, their gravitational destinies already converging. This initial blending of their halos will gradually become more pronounced as the galaxies draw closer, leading to increasingly stronger interactions between their visible disks and eventually to their full merger. It's a grand cosmic play whose overture is already being performed in the silent and invisible realms of intergalactic space. The scientific tools used to detect this halo overlap are incredibly advanced. They include observing distant quasars whose light passes through the halo and is subtly absorbed by the tenuous gas. By analyzing the spectral lines in the quasar light, astronomers can infer the presence and the properties of the gas in the Andromeda halo. Other methods involve looking for faint, scattered stars or using simulations of dark matter to predict where the halos should extend. These sophisticated techniques allow us to probe the most diffuse and elusive components of galaxies, revealing connections that would be utterly impossible to see with visible light alone. It is a triumph of ingenuity and persistent observation, a quiet unveiling of the universe's hidden architecture. The knowledge that the galaxies are already in contact, even if faintly, adds a layer of intimacy to our relationship with Andromeda. It's no longer just a distant neighbor, but a system with which we are already subtly interacting. Our cosmic fate is already intertwined with its own. This connection reminds us of the profound unity of the cosmos, the way in which all things, even on galactic scales, are ultimately interconnected and influenced by one another. It fosters a sense of belonging, a feeling that we are part of a much larger and more dynamic cosmic dance, a grand and slow ballet that has been unfolding for billions of years and will continue for billions more in the silent and majestic dark. When astronomers meticulously mapped the intricate distribution of stars and gas across Andromeda's luminous disk, they made a fascinating and unexpected discovery. The galaxy's disk, this immense and sprawling plane, was not, as one might expect, perfectly flat or uniformly smooth. Instead, it exhibited a subtle, yet undeniable warp. It bends and gently twists like a slow-motion wave or a ripple frozen in place upon the surface of a vast cosmic pond. This warp, though delicate in appearance, is immense in scale, lifting significant portions of the disk, thousands of light years above and below its central and established plane. Such pronounced distortions, these graceful bends in a galaxy's structure, often serve as clear indicators, silent cosmic signals that the galaxy has, in its long history, experienced significant gravitational encounters with other celestial bodies. These interactions, these close passages, or even minor collisions, can subtly pull and gently bend the galaxy's delicate structure. The specific pattern of Andromeda's warp, the way it curves and undulates, strongly suggests that beneath its seemingly calm and elegant spiral arms lies a far more turbulent and dynamic history. Beneath their graceful and familiar shape resides undeniable evidence of ancient collisions of powerful gravitational tides and of slow, but majestic and profound cosmic motion. Even across the immense and stretching distances that separate us from Andromeda, we are able to perceive the lingering ripple, the subtle echo of those past interactions. These faint traces are frozen indelibly into the very stars themselves, each one a silent witness to bygone epochs. It serves as a powerful reminder, a gentle whisper from the cosmos, that no galaxy, no matter how serene or outwardly tranquil it may appear, is ever truly motionless or entirely undisturbed within the restless and ever-changing ocean of the vast and eternal universe. The discovery of the warp was a triumph of meticulous observation and careful data analysis. It's not something that would be obvious at a casual glance. Astronomers had to map the positions and velocities of millions of stars and gas clouds across the entire disk to reveal this subtle but immense deviation from flatness. The techniques involved often use spectroscopy to measure the Doppler shifts of light, which tell us about the movement of different parts of the galaxy. These tiny shifts, when accumulated and analyzed across the entire disk, paint a clear picture of the warp's structure and its extent. The metaphor of a ripple frozen in motion is particularly apt. Imagine dropping a stone into a perfectly still pond. The ripples spread outward, distorting the surface. Now imagine that process scaled up to galactic proportions, and then imagine that ripple being held in place for billions of years by the immense gravity of the galaxy itself. That's what Andromeda's warp represents. It's a persistent echo, a lingering memory of a powerful event that once disturbed the galaxy's serene surface, a silent testament to its dynamic past. The cause of such warps is almost always gravitational interaction with other galaxies. When a smaller galaxy passes close by, or even through a larger one, its gravity can exert a powerful tidal force. This force can literally stretch and bend the disk of the larger galaxy, just as the moon's gravity creates tides on Earth's oceans. The pattern of the warp can often provide clues about the size and trajectory of the perturbing galaxy, and even when the encounter might have occurred. So, Andromeda's warp is a kind of cosmic detective story, a mystery etched into the stars, waiting to be deciphered. The sheer scale of the warp, thousands of light years high, is truly breathtaking. This means that stars in the warped regions are significantly displaced from the central plane of the galaxy. If you were on a planet in one of these warped areas, the Milky Way might appear tilted or even curved in the night sky, a dramatic distortion of the familiar galactic band. It's a reminder that even the grand and seemingly stable structures of galaxies are not entirely rigid, but can be subtly and majestically reshaped by the persistent and immense forces of gravity. The warp is a visible manifestation of turbulent history. It counters the initial impression of Andromeda as a perfectly serene and unchanging spiral. Beneath that calm exterior lies a past filled with gravitational encounters, with mergers, and with the slow but powerful reshaping forces of the cosmos. It suggests that galaxies are not static entities, but living, breathing systems that bear the scars and the memories of their past interactions. Each bend, each twist in the disk is a chapter in Andromeda's long and eventful autobiography, a story written in the language of light and gravity. The fact that we can see this ripple, even across cosmic distances, is a testament to the power of modern telescopes and observational techniques. These are subtle effects that require immense precision, and sensitive instruments to detect. But once revealed, they unlock a deeper understanding of galactic dynamics. It allows us to trace the history of interactions that occurred millions or even billions of years ago, providing a window into the universe's evolutionary past. The light from these warped regions carries the imprint of those ancient events, a silent message from a turbulent epoch. The phrase, "No galaxy, however serene it appears, is ever truly still in the restless ocean of the vast and eternal universe," is a profound conclusion. It encapsulates the dynamic nature of the cosmos. Everything is in motion, everything is interacting, everything is changing. Galaxies are not isolated and unchanging entities, but active participants in a grand and continuous dance of creation and transformation. The warp in Andromeda's disk is a beautiful and tangible reminder of this universal truth, a subtle but powerful testament to the ceaseless and majestic flow of cosmic evolution. It invites us to look beyond the static image and perceive the underlying dynamism, the quiet but powerful restlessness that permeates all of space and time. The study of galactic warps is a significant subfield of astronomy because they provide direct evidence of gravitational interactions that are difficult to observe directly, especially for distant galaxies. By analyzing the morphology, the precise shape of these warps, scientists can build models to simulate the past encounters that caused them. These models can then be used to infer the properties of the perturbing galaxies, even if those galaxies have long since been absorbed or moved away. So Andromeda's warp disk is not just a curious feature, but a crucial data point, a cosmic Rosetta Stone for understanding the process of galaxy formation and evolution across the entire universe. The warp also has implications for the distribution of gas and dust within the galaxy. These warps can create regions where gas is compressed and shocked, potentially triggering new waves of star formation. So, the warp is not a purely destructive or passive feature. It can also be a catalyst for new creation, a dynamic force that reshapes not just the structure, but also the ongoing life of the galaxy. It is a testament to the complex interplay between gravity, gas dynamics, and stellar evolution, all woven together into the grand tapestry of a galaxy's existence. Furthermore, the presence of such a pronounced warp can also provide clues about the nature and distribution of dark matter within Andromeda's halo. The way the disk bends and twists is influenced not just by the visible mass, but also by the immense, invisible gravitational pull of the dark matter halo. By comparing the observed warp to theoretical models, astronomers can refine their understanding of how dark matter is distributed and how it interacts with the visible components of the galaxy. So, Andromeda's warp is a subtle but powerful probe into one of the universe's greatest mysteries, a window into the invisible scaffolding that holds galaxies together. The gentle but persistent bending of the disk over thousands of light years also suggests the incredible strength and reach of Andromeda's own gravity. It takes an immense and enduring force to maintain such a large-scale distortion over billions of years. The galaxy has enough gravitational coherence to hold itself together, even while being subtly twisted and reshaped by external influences. This resilience is a characteristic of massive galaxies, their powerful gravity acting as both a sculptor and a preserver of their grand and intricate forms. Andromeda's warp is therefore a testament to its own immense power and its enduring presence, in the cosmic landscape. The thought of a galaxy being warped like a ripple is a powerful visual. It challenges our mental images of galaxies as perfectly flat and symmetrical entities. Instead, it paints a picture of a dynamic and slightly imperfect, but still breathtakingly beautiful, celestial object, one that carries the memory of its past in its very structure. It adds a layer of organic complexity to our understanding of these cosmic titans, making them seem more like living, breathing entities than simple, geometric shapes. Andromeda's warp is a profound reminder that the universe is always more intricate and more wondrous than we initially imagine, a place of endless and subtle surprises. Galactic collisions are not violent in the dramatic and destructive way that our human imaginations might typically conjure. When two colossal galaxies meet in the vastness of space, it is not a sudden impact, a cataclysmic explosion like two solid objects smashing together. Instead, stars, the individual suns within these systems, will, in almost all cases, rarely, if ever, directly collide. This is due to the truly immense and unfathomable distances that separate individual stars, even within the densest regions of a galaxy. The space between them is so vast, so profoundly empty, that a direct hit is an astronomically improbable event. However, while individual stars may pass harmlessly through each other, the collective and immense gravity of the two merging galaxies will profoundly and dramatically reshape the entire systems. In the specific case of Andromeda, astronomers strongly suspect that its visible and graceful warped disk, along with the faint and ethereal stellar streams that extend into its halo, are the enduring and lingering scars, the silent echoes of such ancient encounters. These are the indelible marks left by past gravitational dances, by slow but powerful cosmic interactions. Long ago, in epochs stretching back billions of years, smaller galaxies, perhaps dwarf systems, may have inadvertently drifted too close to the immense gravitational dominion of Andromeda. They would have been irresistibly drawn inward, only to be slowly and inexorably torn apart by Andromeda's far stronger and more dominant gravity. Their scattered remains, their countless stars, would then have been gently dispersed and absorbed into Andromeda's growing structure, forming vast and luminous loops and subtle ripples that persist to this very day. The galaxy's disk, once likely a perfectly flat plane, would have begun to gradually bend and twist under the immense gravitational stress, much in the same way that the surface of a pond gently ripples and undulates after a small stone has softly fallen into its calm waters. Over the immense, stretching tapestry of billions of years, these subtle distortions, these lingering ripples, have slowly and gracefully frozen into the majestic shape that we observe and marvel at today. By meticulously studying the intricate pattern of this warp and the ghostly stellar streams, scientists are able to reconstruct the long and complex history of Andromeda's many mergers. They can trace the faint and ethereal fingerprints, the cosmic signatures of ancient galaxies that vanished long before the very first spark of life began on Earth. The core idea that galactic collisions are not violent in a human sense is crucial for understanding these immense cosmic events. When we think of collisions, we imagine explosions and destruction. But on galactic scales, the distances between stars are so vast that the concept of individual objects hitting each other becomes almost meaningless. It's more like two immense and diffuse clouds of gas and stars passing through each other, their gravitational fields intertwining and slowly reshaping the entire structures. The violence is gravitational, not physical. The lingering scars of these past encounters are what astronomers look for. These are the clues, the fossil records, etched into the galaxy's structure. The warp in the disk is one such scar. It's a persistent deformation, a memory of a past gravitational tug that has never quite smoothed itself out. These scars tell a story of dynamic interactions, of powerful forces that have shaped Andromeda over billions of years. They are not signs of weakness, but of a galaxy's resilience and its ability to adapt. The idea of smaller galaxies drifting too close and being torn apart by Andromeda's stronger gravity is a common theme in galactic evolution. Larger galaxies, with their immense mass, exert powerful tidal forces on smaller, less massive companions. If a dwarf galaxy ventures too near, these tidal forces can overcome its own internal gravity, stretching it into long streams of stars and gas, and eventually disintegrating it into a diffuse cloud. This process, often called galactic cannibalism, is a fundamental mechanism by which large galaxies grow, accumulating mass and stars from their smaller neighbors. The scattered remains of these absorbed galaxies are precisely what form the faint stellar streams that we observe in Andromeda's halo. These streams are like ghostly trails left behind by the devoured galaxies, their stars, now unbound from their original systems, but still moving in coherent paths that trace their former orbits. By studying the direction, the speed, and the chemical composition of these stars, astronomers can literally reconstruct the ancient trajectories of these lost galaxies and understand when and how they were absorbed. It's a remarkable feat of cosmic archaeology, piecing together a history that spans billions of years. The analogy of a pond's surface rippling after a stone's fall is incredibly apt for visualizing the warp. Just as the ripples gradually fade, but can persist for some time on the water's surface, the gravitational ripples caused by a galactic encounter can endure in the disk of a large galaxy for immense durations. The gravity of the galaxy itself acts as a kind of viscosity, preserving the ripple over cosmic time. This image helps us understand that what we see as a static feature is actually a frozen moment, a lingering echo of a dynamic past. The ability to reconstruct the long and complex history of Andromeda's many mergers is one of the most exciting aspects of this research. By identifying and mapping these stellar streams and analyzing the warp's characteristics, astronomers can build a timeline of Andromeda's growth. They can determine which dwarf galaxies were absorbed and approximately when those events occurred. This allows them to piece together the evolutionary pathway of this colossal galaxy from its earliest beginnings to its current majestic form. It's like reading a cosmic diary written in stars and shaped by gravity. The faint and ethereal fingerprints of vanished galaxies is a powerful and poignant metaphor. It suggests that even after a galaxy has been destroyed and its stars dispersed, its presence does not entirely vanish. Its former existence leaves an indelible mark, a subtle signature, on the larger system that absorbed it. These fingerprints are the only remaining evidence of these lost worlds, these ancient systems that played a role in building the Andromeda we see today. They are silent tributes to the smaller galaxies that sacrificed themselves to create a grander, more luminous entity. The knowledge that these events occurred long before the very first spark of life began on Earth, places these galactic collisions into a truly immense and ancient timescale. It means that the foundational processes that shaped Andromeda were unfolding when our solar system had not even formed, when the universe was a very different place. This profound temporal distance adds a layer of wonder and humility to our understanding. We are looking back, not just into history, but into prehistory, into the deep and primordial past of the cosmos itself. Andromeda's scars are a testament to the universe's long and eventful journey, a silent record of cosmic creation and transformation unfolding across billions of years. The process of gravitational shaping is a continuous one. Even now, Andromeda is likely still absorbing or interacting with smaller companions, leaving fresh but subtle ripples in its disk and adding new streams of stars to its immense halo. The galaxy is not a finished work, but a constantly evolving and dynamic system, perpetually reshaped by the ceaseless and powerful tugs of gravity. The warp and the streams are not just records of the past, but ongoing processes that define the very life and growth of the Andromeda galaxy, a testament to the universe's eternal dynamism. The beauty of these subtle features, the warp and the stellar streams, is that they reveal the hidden life, the silent drama that unfolds within and around galaxies. They transform what might appear as a static and distant object into a living, breathing entity with a rich history and an ongoing story. They invite us to look deeper, to see beyond the surface, and to appreciate the intricate and powerful forces that are constantly at work, shaping the cosmos. Andromeda's scars are not blemishes, the faint shimmer of the Andromeda galaxy, as it graces our night sky, serves as a profound and enduring connection. It links us in a silent and ethereal embrace to a truly vast and immeasurable cosmic story. When your eyes catch that delicate and almost imperceptible light, that ancient glow, you are, in that very moment, witnessing photons, tiny packets of light that began their immense journey, their tireless trek across the universe long before the very first human beings ever walked upon the surface of Earth. That venerable light, that stream of cosmic history, has traveled unbroken and unhurried across the silent and profound void for more than 2 million years. It carries within its essence the indelible record, the quiet autobiography of countless suns, of stellar births and deaths, of cosmic transformations. Deep within that subtle shimmer, that ethereal luminescence, resides the living memory, the silent echo of creation itself. It holds the grand narratives of the spectacular births and the serene deaths of myriad stars. It whispers the tales of the majestic collisions of entire galaxies, slowly merging and gracefully reshaping each other. It embodies the slow and rhythmic breathing of cosmic time, unfolding with an immense and unwavering patience. To truly perceive it, to allow its light to gently enter your eyes, is to be profoundly reminded that everything in this vast and interconnected existence is inextricably linked by the enduring and universal medium of light. The very same atoms, the fundamental building blocks that now radiate and shine within Andromeda's distant stars, are, in an astonishing cosmic twist, the very same particles that once gently drifted and flowed through our own bodies. They are recycled and repurposed from the very same primordial and universal source, a testament to the profound unity of all matter in the cosmos. Its soft glow is therefore both incredibly distant and yet strangely familiar. It acts as a mirror, a luminous reflection of our deepest origins and simultaneously a silent prophecy of our collective and inevitable cosmic destiny. Each and every time its ancient light gently touches the surface of Earth, it serves as a powerful reminder, a quiet whisper, that we are all an integral part of a story, a cosmic epic that is far, far older and infinitely more enduring than the fleeting span of life itself. Through the majestic presence of Andromeda, we are granted a precious glimpse into the endless and breathtaking unfolding of the universe itself. The faint shimmer is not just a visual phenomenon. It's a profound portal. It takes us beyond the immediate present and transports us into the deep past. Each photon, a tiny time traveler, has journeyed across unimaginable distances and immense spans of time to bring us a piece of Andromeda's history. This makes observing it a truly unique experience, a quiet connection to the ancient universe. It's a reminder that even the smallest glimmer can hold the weight of billions of years of cosmic evolution. The indelible record carried by that light is a scientific treasure trove. It contains information about the temperatures and compositions of distant stars, the dynamics of gas clouds, the rates of star formation, and the history of supernovae. Each spectral line, each subtle variation in brightness, is a data point, a clue that astronomers meticulously decode to understand the life of Andromeda. So, that faint shimmer is not just pretty to look at, it's a library, a vast archive of cosmic knowledge waiting to be read. The phrase, living memory, the silent echo of creation itself, is a powerful way to conceptualize the light's contents. It suggests that the light is not merely a passive carrier, but an active repository of cosmic events. It holds the energetic bursts of stellar births, the gentle fading of ancient suns, and the gravitational dance of merging galaxies. It's as if the universe itself has inscribed its autobiography onto these photons, sending them across the ages for us to witness. It imbues the light with a sense of purpose, a storytelling quality that resonates deep within us. The thought that the very same atoms in Andromeda's stars are also the very same particles that form our bodies is one of the most profound and humbling scientific truths. It speaks to the cosmic origin of all matter. The hydrogen and helium were forged in the Big Bang. The heavier elements like carbon, oxygen, and iron, the very stuff of life, were created inside stars and scattered across the universe by supernova explosions. We are, literally, stardust. Andromeda's light reminds us of this deep and unbreakable connection to the entire cosmos. It's a tangible link between the microscopic and the macroscopic, the personal and the universal. The idea of Andromeda's glow being both incredibly distant and yet strangely familiar captures a fundamental paradox. On one hand, it's millions of light years away, beyond our direct reach, a truly alien landscape. On the other hand, its structure, its stars, its elements are fundamentally similar to our own galaxy. It's a mirror, a reflection of what our galaxy is and what it will become. This familiarity, despite the distance, fosters a sense of kinship, a feeling that we are not alone in our cosmic design, but part of a grander, more universal pattern. The reminder that we are all an integral part of a story, a cosmic epic that is far, far older and infinitely more enduring than the fleeting span of life itself, is a powerful call to perspective. Our individual lives, our civilizations, our entire species are but brief moments in the vast and stretching tapestry of cosmic time. Andromeda's light puts our existence into this immense context, showing us that we are participants in a narrative that began billions of years ago and will continue for billions more. This can be both humbling and liberating, a reminder of our smallness, but also our connection to something truly eternal. Through the majestic presence of Andromeda, we are granted a precious glimpse into the endless and breathtaking unfolding of the universe itself. This sentence is a culmination of all the previous points. Andromeda is not just an object of study, but a profound teacher. It reveals the processes of galactic evolution, the grand dance of gravity, the cycles of star birth and death, and the interconnectedness of all cosmic phenomena. It shows us that the universe is not static, but a dynamic and perpetually evolving entity, a grand and ongoing creation. Each new observation, each deeper insight, unveils more of this unfolding, more of the universe's infinite complexity and its enduring wonder. The Andromeda Galaxy is not merely a destination for the focused gaze of astronomers, a distant object of scientific study. Instead, it stands as a profound symbol, a living emblem of the universe's continual becoming, its ceaseless process of creation and transformation. Within its immense and gracefully winding spiral arms, new stars, those brilliant furnaces of nuclear fusion, are constantly igniting, breathing fresh light into the cosmos. Simultaneously, and in an eternal cosmic balance, other stars, having lived out their long and radiant lives, are slowly and serenely fading away, returning their material to the interstellar medium. Entire systems, vast collections of stars and planets are perpetually in the process of rising and then gently dissolving into new configurations in an endless and unwavering cycle of cosmic renewal. To observe it, to allow its light to gently wash over us, is akin to witnessing the very cosmos in the act of breathing. Each and every photon, each tiny particle of light that after its immense journey finally reaches us, carries within its essence the indelible imprint, the silent record of that vast and ongoing story of creation and transformation. In Andromeda's luminous presence, we clearly perceive that the universe, in its boundless expanse, does not, for a single moment, rest. It is perpetually in motion, always creating, always transforming, and forever renewing itself in an unbroken and eternal cycle. Its ancient light has traversed the immense gulfs of cosmic time to deliver a profound message to us. It tells us that existence itself, in its most fundamental nature, is pure, unadulterated motion. It reveals that all things, every star, every galaxy, every atom, are inextricably connected through the ceaseless flow of energy and the universal embrace of gravity. To gaze upon Andromeda, to contemplate its majestic form, is to become a silent witness to creation in its most grand and ongoing progress. It is to perceive an unbroken story, a cosmic epic, elegantly written, and silently inscribed across the stretching tapestry of billions of years. It serves as both a gentle reminder and a profound promise. A reminder that the universe is still in its active phase, still becoming, still evolving, still expanding. And a promise that we, in our small but significant way, are all an integral part of its quiet and majestic expansion. The symbol of the universe's continual becoming is a powerful philosophical concept. It moves beyond just the scientific facts and touches upon the very nature of existence. The universe is not a static machine that was built and then left to run. It is an ongoing process, a perpetual unfolding, a constant state of becoming, of emergence, of transformation. Andromeda, with its active star formation, its aging core, its merging history, and its future collision is a microcosm of this grand, universal principle. The endless cycle of cosmic renewal is a key theme. Stars die, but their elements are recycled into new stars and planets. Galaxies merge, but new structures emerge from the chaos. Nothing is truly lost, only transformed. This cycle is what keeps the universe alive and dynamic. Andromeda's light is a visible manifestation of this cosmic metabolism, a testament to the universe's infinite capacity for self-renewal and continuous creation. It's a comforting thought, in its own way, a sense of enduring life on the grandest scale. The analogy of witnessing the very cosmos in the act of breathing is another deeply evocative and calming image. Just as our own breath is a constant, rhythmic process of inhaling and exhaling, the universe, through its galaxies, inhales gas to form new stars and exhales energy and enriched matter. Through supernovae, this cosmic breath unfolds over millions of years, a slow, majestic rhythm that defines the life of galaxies. Andromeda's light carries the signature of this breath, a visible pulse from the heart of the cosmos. The message that existence itself, in its most fundamental nature, is pure, unadulterated motion, is a profound insight. From the smallest subatomic particles to the largest galaxy clusters, everything in the universe is in motion. Planets orbit stars, stars orbit galactic centers, galaxies drift through space, and the universe itself is expanding. There is no true stillness, no absolute rest. Andromeda's apparent serenity in the night sky belies its incredibly rapid internal motions and its relentless approach towards us. This constant motion is the engine of cosmic evolution, the driving force behind all change and all creation. The idea that all things, every star, every galaxy, every atom, are inextricably connected through the ceaseless flow of energy and the universal embrace of gravity is a unifying principle. It speaks to the profound interconnectedness of the universe. Energy flows from stars to space, from one form to another. Gravity, the unseen hand, binds everything together, from the smallest moon to the largest galaxy cluster. Andromeda's interaction with its companions, its future merger with the Milky Way, and its place in the local group all demonstrate this fundamental truth. We are not isolated observers, but integral parts of a vast and interconnected cosmic web. To gaze upon Andromeda, to contemplate its majestic form, is to become a silent witness to creation in its most grand and ongoing progress. This is the ultimate invitation of the sleepy Science Channel. It's not just about learning facts, but about experiencing the profound beauty and wonder of the universe. It's about connecting with the deep processes of creation that are constantly unfolding around us and within us. Andromeda becomes a lens through which we can perceive the universe's eternal artistry, its ceaseless process of becoming a silent but powerful spectacle that transcends all human timescales. The unbroken story, a cosmic epic, elegantly written and silently inscribed across the stretching tapestry of billions of years, is the narrative that Andromeda embodies. It's a story without a beginning or an end, a continuous saga of matter and energy, transforming and evolving. Each star, each nebula, each stream of gas is a word, a sentence, a paragraph in this grand epic. Andromeda's light is the ink that writes this story across the canvas of the night sky, a timeless tale of creation and change. The final promise that we, in our small but significant way, are all an integral part of its quiet and majestic expansion, offers a sense of peace and belonging, even as we contemplate the immense scales and the ancient histories of galaxies, we are reminded that we are not mere spectators, but participants. Our atoms, our energy, our very existence are woven into the fabric of this expanding universe. Andromeda's light is a gentle reminder of this profound connection, a quiet assurance that we are part of something truly vast and eternally meaningful, a cosmic dance that embraces all life and all matter in its slow and majestic rhythm. As the gentle and ancient light of the Andromeda galaxy slowly and softly fades from the forefront of our conscious thoughts, allow yourself to simply drift along with it into the profound and quiet stillness of the deep interstellar space. Imagine, if you can, floating effortlessly far beyond the familiar boundaries of our own Milky Way. Picture yourself gliding quietly beyond the gravitational reach of any single star, where the only illumination, the sole source of light, is the soft and ethereal glow of countless distant galaxies, each a luminous island, gently lighting the surrounding darkness. In that immense and serene cosmic expanse, everything moves with a slow and perfect harmony. The distant stars, though burning brightly, are utterly silent, their immense energies unheard by human ears. Yet their ancient light hums faintly, a gentle and pervasive vibration within the quiet spaces of your mind. It serves as a soft and comforting reminder that even within such overwhelming vastness, such immeasurable scale, there exists a profound and enduring peace. The universe, in its majestic unfolding, does not, and never has, hurried. It expands, and it continually changes, it transforms, and it evolves, but always, always with an unwavering and immense patience. The galaxies, those colossal, cosmic entities, turn with a graceful and unhurried precision. New stars, the luminous beacons of fresh creation, are gently born within calm and swirling clouds of gas and dust. And time itself, that immense and irresistible river, unfolds like a slow and eternal tide upon an infinite and boundless cosmic shore. You, in this very moment, are an integral part of that same grand and ancient rhythm. You are a precious and unique moment within the immeasurable and enduring story of light. The very atoms, the fundamental particles that now compose your physical body, once quietly drifted and flowed through the hearts of distant stars, much like those you have just peacefully and gently imagined. Their ancient energy, their primordial warmth, now burns as a gentle and steady glow within you, a faint spark, a living ember of the very same ancient and universal fire. Allow your breath to softly and rhythmically follow that deep and unwavering cosmic rhythm. Let your thoughts, those fleeting whispers of consciousness, gently settle and softly dissolve into the profound silence that lies between the distant stars. The universe, in its boundless generosity, asks absolutely nothing from you but quiet and peaceful rest. Its inherent beauty, its majestic grandeur, is in itself more than enough. Its ceaseless motion, its eternal dance, continues its graceful unfolding, whether your eyes are open or gently closed. Somewhere, far across the deep and silent void, the ancient light of the Andromeda galaxy is still patiently and tirelessly crossing the immense distance towards our world. It shines with the very same steady and unwavering calm that it has carried for millions of years, a timeless message from the cosmic past. By the time that ancient light finally reaches our quiet world, you will already be far away, drifting peacefully within the boundless realms of dreams. You will be gently floating among the very stars that shaped your essence, at peace and utterly serene beneath the endless and silent night. good night, the gentle and pervasive hum of the universe, a silent symphony of energy and matter, will cradle you in its boundless expanse. Each distant galaxy, a luminous jewel in the cosmic tapestry, will continue its slow and majestic dance, unseen, yet ever present. The nebulae, those vast and glowing clouds of gas and dust, will softly pulse, with the quiet promise of new stars still forming in the depths of night. Gravitational waves, subtle ripples in the fabric of space, time will continue to flow across the eons, carrying echoes of ancient collisions and the mergers of unseen black holes. These are the timeless rhythms, the deep, unhurried pulses of existence itself. You are now part of that larger and more profound narrative. Your being is interwoven with the very threads of the cosmos. The energy that sustains you, the warmth that resides within, is a direct continuation of the starlight that birthed the elements of your form. It is a legacy stretching back to the earliest moments of the universe, a lineage of cosmic dust and radiant fire. Feel this connection, this gentle embrace of the infinite. Allow it to deepen your sense of calm, your surrender to the peaceful currents of sleep. The universe, in its infinite wisdom, knows no haste. It simply is, and in its being, it offers you a quiet sanctuary. Let the vastness of the night sky be your blanket, the distant stars, your gentle guides. May your dreams be as boundless and as serene as the cosmos itself.